This is problem 12.10 from chapter 12 of Brigham and Houston's Fundamentals of Financial Management, Concise 9th edition. And this convoluted, hard to follow problem, if you go slow and sure and lay out all the stuff, just follow through in a logical manner and just do it line by line. They currently have a machine that they purchased 2 years ago. I don't really care when they purchased it. It has a useful life of 6 more years, a book value of $2,100, and it can be sold at this time for $2,500. So if we replace the machine, we can sell this existing machine for $2,500 today, but we'll give up the $350 of depreciation on this expense that we're claiming as expenses over the next 6 years. If we don't replace the old machine, we could sell it for $500 at the end of its useful life. So perhaps the easiest way to start out is, what are the effects if I keep the machine, and what are the effects if I sell the existing machine? Okay? So if I keep the machine over the next 6 years, let me start with time 0. 1, 2, 3, 4, 5, 6. If I keep the old machine, my depreciation expenses for the next 6 years will be $350 a year. Okay. DEPREXPN, depreciation expense. All right, so, and then sell for scrap at the end of the 6th year, I would be able to sell the machine for $500. All right, so if that's keeping the old machine, I'll still get this depreciation and I'll get $500 in scrap. If I replace the machine, today, I could sell the machine for $2,500. So I'd get $2,500, but $400 of that gain would be taxable because it's got a $2,100 book value. If I sold it for $2,500, that's a $400 gain, and at my 40% taxable, okay, so if I sold it for $2,500, $2,500 minus $2,100 would be the gain on the sale, and so I'd owe $160 in income taxes on it. All right. So if I did sell that machine, I'd have to buy the new machine, and the new machine, it cost me $8,000, given in the problem. But it'll last for all these good years. It'll have an estimated salvage value of $800. Okay, if we use it all 6 years, that when we sell it for $800, it'll have a book value of 0. So, sell at end of year 6. That'd be a positive $800 gain. But I'd owe 40% taxes on it. All right. The operating cash flows I would be claiming depreciation on the new machine. Depreciation on the new machine. And I'm just going to put these percentages up here so I can use cell references. 20%, 32%, 19%, 12%, 11%, and 6% in the final year. All right. So I could get my depreciation expense on the new machine would be $8,000 times these percentages. So the $8,000 would be expensed over the 6-year period, 20% of it, 32%, 19, 12, 11, and 6. Okay? So there's my depreciation on the new machine. And let's see what else. Sales are going to increase by $1,000 a year. And that'll be a positive number for the next 6 years. And operating expenses will decline. $1,500, which is the same as increasing profit by $1,500. All right, I've got an increase in inventory of $2,000. And the increase in inventory of $2,000 is offset by $500 of accounts payable. So the way this is worded, these are not initial investments, it's actually operating cash flows. Convoluted wording. But accounts payable simultaneously increases by $500. So net, we would have a times 0 increase. Well, we'll do increase in inventory, which will be an outflow, and then the increase in accounts payable would be an inflow. Trouble is that when I scrap the machine out here, I'm going to get a reversal of these two. Okay, so those are terminal cash flows and initial investments. All right. Am I missing anything else? Should it replace machine? All right, so we've written down everything. My initial outlay. Would be the gain from selling the machine minus the tax on it, the cost of the new machine, the increase in inventory offset by the increase in accounts payable. Okay, so there's my initial outlay, $71.60. The after-tax operating cash flow is going to be a little bit more convoluted, okay, but if I take the increase in sales and it's offset by and add to that the decline in operating expenses. And then I subtract from that the depreciation expenses on the new machine. But while I'm doing that, I also have to remember that the new machine's going to increase depreciation $1,600, but I had to give up the $350 in each of these periods. Okay, so this would be the negative on that depreciation, and then add back that one. So the net change in depreciation, it would have gone down by, the depreciation expense would have been $350. It's actually increased. So we're only using the marginal change, which would be the $1,600 minus the $350. That's your marginal change. Okay, so that'll be the change in EBIT. Take all of that mess, times 1 minus the tax rate of 40%, and then add back the net increase in depreciation. All right, so there's my after-tax operating cash flows for each of the 6 years. All right, making these. And then I have my terminal values. And I've got a selection of these to go by. Remember, if I kept the old machine, I could have sold it for scrap at this period, and I'm not going to get that. All right, so if I'd have sold it for scrap here at 500, I guess I should have added a line, sell for scrap and tax on scrap sale. So I would have netted $300 from the sale, $500 net of the $200 in taxes. All right, but if I replace that machine, I give up those amounts. Okay, so for my terminal values, I would give up that $500, but I'd also give up having to pay taxes on that. I will get that $800 minus the tax I pay on it. I will recover the inventory investment, but I'll have to essentially pay back the accounts payable. But anyway, through all of that, that's my terminal cash flow. Terminal cash flows, plural, I guess. So the total cash flows for each of the 6 years. And the problem tells me that the weighted average cost of capital is 11%. So, doing my calculations, the internal rate of return on this is actually 20%. So I can already tell it's a good idea because it earns 20% and only costs 11. From an NPV standpoint, the present value of the future cash flows so that money coming in over the next 6 years, the net amount coming in over the next 6 years is $9,000. The initial outlay is a little over $7,000. So my net present value be $1,908. So positive NPV, IRR greater than WACC, decision rules support replacing the machine. And that's the convoluted set of answers, but should it replace the machine? Yes.